All right, so this is just a very quick tutorial on working through this worksheet, and then I'm going to demonstrate what I do with the test and the test key. But the point of this tutorial is just to get you kind of oriented to basic Excel functions so that you can begin managing your data sets in Excel. Certain scientists have very particular feelings about this. Some people really don't like doing Excel because you can do a lot more, but that's also room for error to seep in. But I'm a big fan of doing it here because not only can you color code things, but I feel like the diversity of functions really helps you manage your data. And just right off the bat, I want to note that there will be times where you have errors that pop up. Sometimes, if you don't finish a function, for instance, it's going to say, hey, like, what? What are you doing? Or sometimes you'll have a function that you've written wrong and it'll say, hey, like, I can't compute a value for that. That's totally normal and it's to be expected in the process. In fact, sometimes I force these um, to see where my code is going wrong. And so just know that if you're getting a lot of these, don't despair. It's all part of the process. But jumping right in, let's talk about how to make a function in Excel. So as it states over here, to make a function, you will just use the equals sign, and it has to be the very first thing in a cell, because if you put anything else first, it will not run it as a function. But if I write it as a function, then it is looking for some calculation to run. So for instance, if I put an S and then an equals and then do 1 plus 1, that's not going to run because it is thinking it's a general cell with no computation happening. But if I just put the plus first, then all of a sudden it runs the equation, in this case 1 plus 1. And you can do very basic or complex calculations here. So I could do this times for or whatever that number is, and in this case it's so big it can't even represent it. But there's complex equations that you can do, but often you will not be writing mathematical functions just like this. More often than not, you will be using cell variables. And so what that means is when you reference a cell after an equals sign, it means that it is going to look at, oh, and I need to fix this code. It is going to look at whatever is in that cell and mimic it. So in the same way where you have an x as a variable in lots of mathematical equations, you just have cell coordinates in Excel. So in this case, this cell is located in the column A. Whoops. It's located in the column A and at the cell 9. So if I do equals A9 and just type it in like that, it's going to pull in that information. I can also just click on the cell and it will do it for me. The other thing that I can do is I can use cells as variables. So in this case, we've got 3 numbers off to our right here. And, oh, I don't know why all of these numbers are off now. Anyway, what you'll do is you will simply put an equal sign, and then you will select each of these variables that represent the value contained in their cell, because here clearly we see that a cell coordinate just represents whatever's in that cell. So if we do it like this, then it'll add it up and we will get a 9. So we can do it like that. I also wanted to note that I clicked on these as I put each plus in. You can also just type in the coordinates and it will highlight them just the same. I think that that is a short-lived thing because it's so much easier to just click on them, but just know that that's an option. Sometimes you don't want to have to write in every single mathematical numerator or operator within a function. And so you can use built-in functions within Excel. So in this case, using the sum function. And what that means is we're just going to type equals, and then we're going to start off our equation by typing sum. And you can either hit tab when it highlights it like this, which will automatically capitalize it, or you can type it in manually. And it'll capitalize it just like that. The other thing that you can do is you can just type it in and then put in a parenthesis, And that will also achieve the same end goal. And most functions will always have that first part, and then you put a parenthesis for you to activate the function. So in this case, if we're trying to activate the sum function, we're going to then throw in that parenthesis. And then it's going to ask us for, it says number 1, number 2, etc., etc. And we can do this a few different ways. We can select each one and put a comma in, and in the end, it will sum up those values. Or what we can do is we can use a colon. So in this case, I can select the first one, select colon, and then select the bottom one, and it is going to select all the values within that range. That's what the colon indicates in Excel. And in this case, it's going to sum all of those numbers, and that was a lot faster than putting it in manually. The other thing that you can do is rather than click and then click the one at the bottom right using the Shift key, I should have noted that, you can just click and drag and then put that bottom or that end parenthesis and hit enter. So there's a few different ways to get at your data. Another thing to note, and you've probably seen me do this a few times now, is when you click in your function up here in the top banner, it'll highlight what data is being sourced in the function. So for instance, if I had, and I'll explain this in the next step, if I had another range of data over here that I also wanted it to sum, when I select up here, it's going to show me both of those ranges that I've selected. But in this case, we're just going to sum all the data that we have, and then we get our value. Next, we're going to use an average function, which is a pretty common function that you use in psychology because we depend on a lot of averages. And so we are going to average all of this data to the right. And this is where it becomes really important to use those functions or those techniques I was just talking about, where you either drag and select the whole area, or you click and then click Shift and select that bottom right one, because that speeds up the process a whole ton. And you see that that works pretty quick. All right, so now we're going to move on to selecting specific cells that are not within a continuous streak, because sometimes we only want like every other cell, which is what we're going to do in this case. So what I'm going to do is I'm going to type sum to get our equation started up, and I can do this one of two ways. I can, like before, click and then put a comma, and then click and put a comma, click and put a comma. Oh, whoops. Let's get the right one there. And then hit enter, or I can hold down control as I do that, which speeds things up. So I'm holding down control on my keyboard right now, and then I can just select each of those, put that bottom parenthesis, and we are good. Okay, so now that we are getting into more advanced techniques, I'm going to show you what I alluded to earlier, which is selecting multiple ranges. So again, like we were doing up here, we do not want to average some of these text-based columns, and we only want to do the ones that are every other column. So much like we were doing before, we can include multiple ranges in our function. So we're going to hit average, and the way I did that so fast is I just typed the first few letters, it highlights it, and then I hit tab, just so you know. And then I'm going to highlight that first range. Then I'm going to hit a comma. I'm going to select that second range, comma, third range, comma, fourth range, comma, and fifth range. Of course, the other way that we could do this function is we could just hold down control, and it will automatically throw in those commas for us. Whoops. And the only downside to this is if you select the wrong range, then you have to manually go back and remove that. Man, I did it again. Let's try this one more time. There and there. Perfect. And that gets us the same result. Okay, so when you're validating data, Excel is really helpful for identifying where data is missing. It's not foolproof because sometimes Excel thinks that there's data when there isn't, but most of the time, using this isBlank function can determine a true or false question, or it gives you a true or false output, determining whether a range or a cell is blank. So in this case, if we type in isBlank, And then it's going to ask us what cell we're talking about. So if we just wanted to know with a single cell, we could just close it up like that, and it's going to say true, this is blank. Versus if we were to select the next cell over, which I'm going to indicate by typing F. Let's see, F41. It's now going to say false because there's something in there. We can also use this to check out an entire range of functions, and that's going to return a spill function. And there are certain functions that cannot take ranges like this without them having room to show identifiers for each area that we have designated we want information on. So in this case, it wants an isBlank function in each of these cells, but the problem is that there's already data there, so it can't do that. So usually what you do in these situations is you have a whole matrices of isBlank functions. But in this case, we're just going to revert this to that first cell. Okay, so now if we do it with one that has data, it's going to show us false. All right, so one thing that becomes really annoying as we clean data is writing a new function every single time, especially because in some of these cases, you're probably saying, Jonah, you could just add these up in your head, or you could like just do this on your phone calculator. And the problem is yes, you can, but as you'll see with our test key, sometimes that would take a long time, and we don't want to have to rewrite this function that many times, be that in our phone calculator or elsewhere. So we can use what is called a function drag. And to do this, we are just going to write a function concerned with our initial set of data. So in this case, if we are just interested in summing these values to the right, we are going to select all of them and hit enter. Now, if we wanted to run that same function for everything else in this range, we would need to either rewrite that function each time, or we could drag our function and it will reassign based on where this cell is looking. So in the most simple terms, what this means is this cell, relative to this cell, it is looking 2 cells to the right, and then it's selecting data for 9 or 10 cells. So if I hover over the bottom right of this function and drag it down, it is going to generalize that function structure to these other cells. And so now you see that rather than it being this row, this next function is looking at this row. And that speeds things up exponentially for us as we are cleaning data, validating data, calculating variables, and so on. So something to note there. There is something that's a little more advanced that I'm just going to allude to. I don't want to freak you out with this, but sometimes you only want one part of the equation to change. And you can always constrain certain parts of it by putting a $ in on either the column, so this is going to constrain the column, and this is going to constrain the row. So if I put those in there, it's saying, hey, even if I drag the function, don't change the column, and even if I drag the function, don't change the row that I'm looking at. And so if I drag this down, all of a sudden each of these is looking at a different, or is looking at the same row. But again, that's a little more advanced. For now, we're just going to work with the basic functions. All right. So now we are getting into what is the most important function that you need to know if you are using Excel to validate data, to calculate measures, and so forth. And that is the if function, because this allows us to, in procedural order, answer yes or no questions. And the basic structure of an if function is you write equals if, and you throw in that parenthesis, and it says we're going to do a logical test. And what a logical test is it's going to return a true or false. Is the statement in this section of our function true or false? So in the example I've got here, I'm going to look at whether this cell is above 18. And if that's true, then it is going to proceed to this part of the function and output whatever is in the value if true section. However, if this is not true, it is going to return the value if false function. So as I've written to the right, we are going to look at this and type in 18 to identify if that value is above 18. And if that's true, we want it to output a 1, perhaps if we're dummy coding. And if that's not true, we want it to output a 0. And since this is 17, which is clearly not above 18, when we output, or when we hit enter, it is going to output the false part of that. And we could change this number to be just about anything we want. So if we wanted a 1 or a really long string, we could put that into the false section of the Excel function. But for now, we'll settle with 0. The other cool thing that we're going to practice as we did it before is dragging that Excel function, or is dragging that if function. So it is going to take this part of our function and change things relative to, also sometimes if you find that you're pausing my previous monologue, you see me a lot where I'm in here and I'll select a different cell and it'll be like, do you want to look at this cell? Just hit escape on your keyboard if that keeps happening to you. But we are going to drag our function down. And now it is going to be looking at this cell, and this cell. And this works wonders if we are validating data. For instance, in some of the data that I'm currently cleaning, there are massive swaths of data that sometimes need to meet a certain threshold or criteria. And when that's the case, I just have a simple if function going through and saying, okay, does this data meet the requirement? 1 if yes, 0 if no. So that's going to be very helpful. The other thing that we can do that might ease interpretation as you work with if functions is you don't always have to put a number in the true or false sections. We can also put things within quotations. And what Excel does is it treats anything in quotations as a text string. And so even if we put numbers in between 2 quotes or even a subfunction, it is just going to output whatever is in between those 2 quotes. So in this case, if we wanted to know whether each of these cells is blank or not, and then tell us this cell is blank or this cell actually has something in it rather than a 1 or a 0, we would write if, and then the logical test in this case is we're going to use our isBlank function. So you'll notice that I'm nesting a function that's not a mathematical function in our if function, which we can do super easy. The thing that you'll note too is now I have different colored parentheses. And the purpose of that is for Excel to show you which parentheses belong to which sections of your equation. As you'll note here in a minute, when I put this back parenthesis on, it is going to be black, just like that first parenthesis. If I put in extra parentheses or other functions, it will change other colors. And the purpose of this is sometimes you'll have really complicated if functions that have lots of parentheses. And so it kind of helps you to triangulate which parenthesis belongs to which function. But I digress. In this case, we're just going to throw a comma after that because this is going to return a true or false, as we saw before. And if the value is true, we're going to have it output cell is blank. That's the value if true. And if we put a comma, it's then going to ask us, all right, what do we do if the value is false? Then we're going to say cell contains something. We're going to put the end parenthesis, or the end quotation, and then the end parenthesis. And then we're going to hit enter, and it's saying, hey, there's something in this cell. And if we drag that, it's going to then go through and in text tell us what is happening. Okay. So now we are getting to the final, probably most complex, but most relevant thing that you will do when you are using if functions or cleaning data. Because really, when we are cleaning data and trying to validate what is and is not there and what does and does not meet certain thresholds, we're pretty much just asking lots of yes and no questions. In this case, we are going to look at how much of our data is here and in what combinations is it here. So if I wanted to know first, okay, does this first column of data exist? And then second, does this column of data exist? And depending on what it says, I want it to tell me, okay, the first cell is blank, which means that I'm going to stop. If this doesn't have data, then I don't want to proceed anymore. But then I also want it to move to this next cell. And depending on if this cell has data, I want it to either tell me, okay, no, this cell is blank, we only have partial data. Or finally, if both of these cells have data, I want it to say all cells have data. And the only way that I can ask two questions using the same function is by nesting a second if function within an if function. So up here we had two outputs, right? So in this case, we are going to write the function as we normally would. So if is blank, and we're going to target this first cell. And then it's going to ask us, all right, if that's blank, what do you want us to tell you? And if this is blank, I want it to tell me first cell is blank. Okay, but now it's going to ask me, what do you want to do if it's false? And I could just say, this cell is not blank, but then that doesn't answer my second set of questions. So what I'm going to do is I'm going to put another function in the value if false place. So I'm going to hit if, and now it's going to set up the exact same structure that we had before. And it is asking for another logical task. So I'm again going to ask it to say is blank, but now I'm going to have it ask the question of is this next cell blank? And I'm going to close that up, and then I'm going to tell it what to do if the value is true. So if that one's blank, we only have partial data. So I'm going to tell it, okay, tell me it's partial data. And the value is false. I want it to tell me all cells, if I can spell, cells have data. And now I have to close not only this function, but also the first function. So now you see how this and this are the same color, but now when I add the next parenthesis, it's matching with the color of this first parenthesis. So then when I run this, it is going to say, all right, this one has data, but this one didn't, so we're at partial data. And one of the most important things to understand with this is that it goes through these things sequentially. So it is going to look at the first part of the equation first, meaning that I get no information on this second cell, even though I have part of my function that's looking at that cell, if the first part of the equation is fulfilled. So if the first one is blank, it just says the first cell is blank. It doesn't even look at the second one. But if the first cell isn't blank, then it looks at the next one. So you kind of understand that there's an order to these functions. And then what we're going to do is we're just going to drag our function and see all of our different outputs. Okay, so that's the end of the formal training. I am going to really quickly go through these supplemental functions and kind of their use cases, but I'm going to do so in a separate video. After this, there's going to be a third video where I just demonstrate how to go through and clean data using these different techniques. And I'll show you some extra ones that I haven't even talked about. So stick around for video 2 if you're interested. I'm sounding like a YouTuber, bro.